A thin red ember hangs in the dark, not bright enough to feel warm, not distant enough to feel harmless. Proxima Centauri, our nearest stellar neighbor, sits there like a watchful eye that never fully closes. On the screen, a calm line begins to form. It isn't a picture of an exoplanet. It isn't a photograph of an atmosphere. It's a pulse, a slow, deliberate rise and fall and radial velocity curve stitched together from countless moments of starlight. Each point is a measurement. Each point is also a question. This is the promise and the threat inside the tidal RV line on Proxima b, activity cycles versus planet the full story. A single RV line that seems to describe Proxima b, and yet across time the signal has refused to fit like a clean, obedient orbit should. The case looks simple from far away. Up close, it starts to move. The key question is blunt, almost unfair. What does this wobble actually mean? Because radial velocity is not a camera. It's an inference. It measures a star's motion toward us and away from us by tracking tiny shifts in the star's spectral lines, light stretched and compressed by motion. The exoplanet in this method is never seen directly. It is felt, a gravitational tug, a rhythmic insistence in the data. And the most haunting part is this stars can impersonate that rhythm. In an ideal world, quiet star, perfect instrument, an exoplanet signal would look like clockwork, the same pattern, the same timing, a steady beat. A real planet should produce a repeatable periodic signature because orbits, barring complications, are stable patterns written by gravity. But Proxima is not a quiet star. It is the kind of star that makes you earn every claim you want to make about the habitable zone and every future sentence you might hope to say about an exoplanet atmosphere or the signs of life. So we begin with a discipline older than any telescope. We treat the attractive answer as guilty until proven otherwise. Here's the tension pair plain, an unavoidable signal versus artifact. The signal says a planet is there, a small world Proxima b pulling its star in a tiny repeating dance. That's what the RV curve implies when you fit it as an orbit. The artifact says the star itself is making the dance. Stellar surfaces are not uniform. Dark spots, bright faculae, magnetic storms. These features rotate in and out of view. They reshape spectral lines. And when spectral lines change shape, the measured radial velocity can shift even if the star's center of mass barely moves. That's not a philosophical problem. It's a concrete false positive pathway. In other words, the wall creaks, and we mistake it for footsteps. There's a reason this matters beyond a single debated curve. The entire search for life on exoplanets, every future claim about a biosignature, every whispered possibility of a technosignature rests on the integrity of the first step. Is the planet really there? And do we truly know its orbit? If the detection foundation is unstable, then atmosphere interpretation becomes a castle on fog. So the story isn't we found a planet. The story is we found a pattern. And then we had to decide what kind of universe produces it. We watch the line, the calm pulse on screen. It looks like certainty because the human brain loves smooth repetition. But the title's hook is that this repetition isn't fully loyal. The RV line seems to shift when you compare it across activity cycles, the star's own seasons of magnetic behavior. That's where the story turns ominous. Not because anyone did something wrong, because nature is allowed to be complicated. So what would we expect if this really is a planet? We would expect the signal to keep its rhythm and shape even as individual measurements get noisy. We would expect it to survive independent ways of looking different slices of data, different seasons, different diagnostics. We would expect it to behave like gravity. And what would we expect if the star is the author? We would expect the signal to breathe with the star, to change amplitude or shape as spots and faculae evolve, to appear strong then soften, to line up suspiciously with other signs of stellar activity, to work beautifully in one stretch of time and then quietly stop working. That's what it means for a signal to refuse to fit. Not that the curve disappears, but that its story changes depending on when you listen. Now, one brief calibration just to set the scale, and then we return to Proxima. When people hear planet, they imagine something obvious, a disk, a dot, something you could circle in red ink. But here the planet is smaller than the noise sources trying to impersonate it. That's the modern edge of exoplanet science. The most important worlds can live inside the tiniest measurements and the most convincing mirages. So we hold two truths at once, because the outline demands honesty. Radial velocity can detect tiny stellar motions and has revealed many exoplanets. Active stars can mimic those motions through changing surface features and magnetic variability. A stable exoplanet should leave a repeatable signal. Activity-driven signals often evolve with time, and then the long shadow at the end of the chain. If Proxima b is real, and its orbit can be nailed down cleanly, it becomes more than a nearby headline. It becomes a candidate for the next phase of exoplanet science, one that tries someday to say something about an atmosphere, and only much later, whether any chemistry might resemble a biosignature. But speculation can't come first. Not here. Not with this star. Because there's an explicit confounder that has to be named out loud before anyone gets to hope stellar contamination. Spots and faculae, activity cycles, the star's changing face. This confounder doesn't just add uncertainty in the abstract, it can manufacture a planet-like RV signal from nothing more exotic than a rotating, evolving surface. A perfect false positive machine if we're not careful, which means the line on the screen is not the end of the story. It's the beginning of a trial. To know what the wobble means, we have to step into the machinery that made it how starlight becomes numbers, how numbers become a curve, and how a curve can fool even careful people when the instrument is fragile and the star is alive. So we go closer, into the spectrum, into the calibration, into the place where the exoplanet disappears entirely, and all that remains is light shifting by an amount so small it can be mistaken for a breath. And that is where the next section begins. The light arrives first as something almost disappointingly ordinary, a stream, a steady wash of photons from Proxima Centauri, collected and fed into a machine that turns starlight into a record dark lines and bright gaps of barcode of chemistry and physics. Then on the screen those lines shift, not by a distance your eyes can trust, not by anything you would call movement in daily life, a fraction, a whisper, and yet the entire claim of an exoplanet can hang on that whisper. This is the part of the story where we stop talking about Proxima b as a world, and we talk about how we manufacture the RV line in the first place. Because the title is not just a mystery, it's a test activity cycles versus planet. The RV signal has refused to fit cleanly, and before we decide who's guilty, the planet or the star, we have to see how the evidence is made. Radial velocity is built from spectroscopy. You measure the star spectrum again and again, and you look for tiny Doppler shifts, starlight stretched when the star moves away, compressed when it moves toward us. The planet's gravity is supposed to create a repeating pattern in those shifts. That pattern becomes the RV curve, but measure is a dangerous word. It suggests something direct, something you can point to and say there. In truth, RV is a chain of decisions. First decision, where do we anchor the measurement? You can't just look at one spectral line. Lines can be noisy, blended, or distorted. So you combine information across many lines, letting the whole spectrum speak at once. That's how you get enough precision to see a small exoplanet's tug. Second decision, how do you keep your ruler from moving? Because the instrument itself is a physical object. It expands and contracts with temperature. It flexes, it ages, it can drift. The star's motion you're trying to detect is so small that the instrument's own behavior can become the dominant story. This is where calibration drift enters like a quiet antagonist. So we build calibration into the process. The spectrum isn't just taken, it's referenced, compared against a stable wavelength yardstick, corrected, verified. That's the only way the RV line can be more than a drawing. And still, this is not enough, because even a perfectly calibrated instrument can faithfully report a lie the star is telling. Here is the key evidence move. In this section, we don't just measure the star's apparent motion, we also measure the star's state. We watch for telltales of stellar activity signs that the star's surface and magnetic environment are changing in ways that can masquerade as motion. Activity doesn't just add noise, it changes spectral line shapes. It can tilt the playing field under your feet. So the RV pipeline grows a second spine activity diagnostics, not because we're curious, but because we're suspicious. And that suspicion has a concrete form. If the RV signal rises and falls in step with activity tracers, if the planet appears most strongly when the star's surface is most disturbed, then the star becomes the more plausible culprit. The signal begins to look less like gravity and more like weather. There's another crucial test hiding in plain sight. Does the RV shift look the same at different wavelengths? This is where the story becomes almost elegant in its cruelty. A real planet pulls on the star's center of mass. That motion does not care about color. Gravity is indifferent to wavelength. So a true planetary RV should appear consistently across the spectrum, but starspots and faculae do care about wavelength. The contrast between a spot and the surrounding surface is not the same in all colors. The shape distortions they cause can be stronger in one part of the spectrum than another. So if the RV signal changes with wavelength, if it behaves differently in different spectral regions, that's a fingerprint of stellar contamination, not an exoplanet orbit. This is the chromatic RV idea, a way to interrogate the signal's origin without ever seeing the planet. Notice what's happening. We are building a courtroom where the evidence is cross-examined. The titles promise RV line on Proxima B. The full story is really a promise about credibility. It's the story of how a signal can look persuasive, then refuse to fit when you demand that it survive every diagnostic. Signal versus artifact. Planet versus activity cycles. But we have to admit with quiet honesty that the method has its own ghost even before the star speaks, because instrument behavior can imitate patterns too. Instrument systematics are not just random mistakes. They can be structured. A wavelength solution that shifts subtly. Thermal stability that isn't perfectly stable. Detector effects that nudge line positions by tiny amounts. Any of these can write trends into the RV time series trends that a human mind will happily interpret as a planet if the period seems plausible. So another confidence builder enters redundancy. If independent instruments, independent reductions, independent teams recover the same RV behavior, the chance that it's a single calibration artifact falls. Agreement doesn't prove the planet, but it raises the bar for non-planet explanations. And in the case of Proxima, where stellar activity is an ever-present confounder, agreement is not a luxury, it's survival. Now we step back for one brief calibration, 2 sentences, no more. This is like listening to a song on a record player. If the turntable speed drifts, the pitch changes, and you might blame the singer. The entire how we know is about proving the turntable is steady before you diagnose the voice. So what do we actually have at the end of this pipeline? We have an RV curve, the RV line, a candidate periodic signal that can be fitted by a planet model. We also have a set of checks that ask relentlessly, does the signal track stellar activity? Does it behave consistently across the spectrum? Does it survive calibration, scrutiny, and instrument cross-checks / And here is the uncomfortable truth that makes this story worth telling. Even with all this, a star like Proxima can still fool you, because activity is not a single knob you turn down. It evolves, it has cycles, it can temporarily align with an orbital timescale and mimic clockwork. And if you only observe in certain windows, your sampling can conspire with the star's behavior to create a pattern that looks stable until it doesn't. That means the method's greatest strength. Its sensitivity becomes its greatest vulnerability. The closer we get to Earth-like signals, the more we are measuring the boundary between planet physics and star physics. Which brings us directly to the next move in the story time. If a planet is the author, the signal should remain itself. If the star is the author, the signal should change masks. So now we stop staring at the machinery and we watch the RV line across seasons, across activity cycles, looking for the moment it refused to fit like a planet should. A red surface turns slowly in the dark. Not smooth, not silent. A star is not a light bulb. It is a body with weather patches, scars, bright seams, dark bruises that come and go. In our minds, the planet is supposed to be the suspect, the unseen exoplanet Proxima b, tugging on its star and leaving a clean signature in radial velocity. But this section asks us to do something harder, a change of perspective. We look away from the invisible world and stare directly at the star. Because the title isn't shy about the conflict activity cycles versus planet, the RV signal has refused to fit like a simple orbit, and the most honest next step is to treat Proxima's stellar activity as an active player capable of forging a false positive that looks like a planet until you interrogate it with time. Here's the key question now. If the RV line is tracking the star's changing behavior, what patterns would expose a stellar imposter? We begin with the simplest rule of thumb in plain language. A planet pulls like a metronome. A star changes like weather, but weather can have seasons. Star spots and faculae, dark and bright regions on the stellar surface, rotate in and out of view as the star spins. They distort spectral lines. They change the apparent balance of light from the star's approaching limb and receding limb. That can shift the measured radial velocity without a planet moving anything at all. This is stellar contamination in its most physical form, the star's surface heterogeneity becoming a fake Doppler shift. And then there are activity cycles, longer rhythms in magnetic behavior, patterns that can wax and wane, changing the character of the star over time. Even if you never name the mechanism, the effect matters. The star does not remain the same instrument from one season to the next. So we watch for evolution. This is the evidence tension in section 03, and it's exactly what the outline demands. Token C at the center. The RV line tied to activity cycles over time. If the planet is real, the signal should keep its basic identity, its timing, its shape, its relationship to itself, while noise scatters around it. If the star is manufacturing the signal, you expect something else. The RV signature should breathe. It should change in amplitude, or warp in shape, or slip in phase as surface features evolve, not always dramatically. Sometimes in small betrayals, the kind that only appear when you lay observing seasons on top of each other and ask them to agree. So we do that. We compare then to now, not with nostalgia, with suspicion. And the title thread tightens the RV line on Proxima b, the full story. The full story is not a single curve. It is the curve across time, across activity cycles, where the signal can refuse to fit a single clean planet model. Now, the star's impersonation has another trick. Time itself can cooperate with the lie. If your observing is uneven clusters of data here, gaps there, then you can accidentally sample the star in a way that makes activity look like clockwork. That's the confounder called time variability versus sampling, windowing, aliasing. The pattern that appears not because it's real, but because of when you looked. This matters because it can create an illusion of stability. If you only catch the star in one mood, you might mistake that mood for an orbit. And when the mood changes, the signal starts to look inconsistent, like it refused to fit, and the argument begins. So the tests become concrete. We ask, does the RV signal align with independent signs the star is active? If RV rises and falls when activity diagnostics rise and fall, the star's case strengthens. We ask, does the signal's character remain constant across observing seasons? A planet should be stubborn. A star should be fickle. We ask, does the RV curve look equally convincing in different subsets of the data? Or does it depend on which months and which activity state you include? Dependence is a clue. Stability is a clue. And then we allow a more uncomfortable possibility, because reality is often not an argument with only two corners. It might not be planet or star. It might be planet and star where a real planetary signal is present, but activity adds a second shifting signature that partly overlaps and partly interferes. In that case, the RV line would not be wrong. It would be composite, a braided rope of gravity and stellar weather. That possibility does not rescue us from skepticism. It deepens it, because a composite signal means a simple model can mislead you in either direction. Over-attribute to the planet, and you inflate confidence. Over-attribute to activity, and you erase a real exoplanet. This is where uncertainty isn't an embarrassment. It's the honest shape of the problem. So we lean into the tension pair that defines this channel, signal versus artifact. But now we add a third phrase, signal versus artifact over time. This is the closest we come in the section to a moral statement. And it's not really moral, it's methodological. If you want to talk about an exoplanet atmosphere someday, about possible biosignature chemistry, about any future technosignature clue that could only make sense if the planet exists, then you must first survive the star's attempt to impersonate the planet. Because the star is always in the data, even when you think you're looking at the exoplanet. And now we've built enough pressure that the story has to answer the next question. What is the strongest defensible claim given all this planet star? Or a hybrid? We turn toward synthesis, toward the moment where we put the models side by side and admit what they can and cannot say. We move from suspicion to judgment, carefully, reluctantly knowing that the line has already refused to fit a single easy story. So we step into the next section, where the curve is no longer a mystery to admire, but evidence to weigh. Two transparent curves hover over the same set of points. One line is clean, confident. It treats the radial velocity signal as a simple orbit, planet only, gravity only, as if the star were a silent stage. The other line is clever in a different way. It tries to explain the same wobble as the star's own behavior, activity, only surface only, as if the exoplanet were a story we told ourselves. And then there's a third path, not a compromise for the sake of peace, but a recognition of what the data can force you to admit, a hybrid line threading between them, trying to honor the fact that Proxima is noisy and nature rarely signs her name in one ink. This is where the episode stops flirting with certainty and makes a statement that can survive daylight. Best current conclusion. Proxima b is plausible, possibly even the best explanation, but the case is not clean. That sentence is what the title has been demanding all along. RV line on Proxima b activity cycles versus planet. The RV signal has refused to fit perfectly across activity cycles, and that refusal is not a footnote. It's the central constraint on what we can responsibly claim about this exoplanet. So what can we say without reaching beyond the outline? We can say what the method supports, and we can say what the confounders threaten. A planet interpretation begins with a repeating pattern in radial velocity, the star's light shifting as if the star is moving toward and away from us in a steady cadence. This is the foundational observation, an RV curve assembled from many spectral measurements. Around an active star, that same kind of curve can also be manufactured by stellar activity spots and faculae, reshaping spectral lines, magnetic variability, adding structure activity cycles, changing the star's fingerprint over time. So the conclusion isn't a slogan. It's a synthesis, what survives the cross-checks and what remains vulnerable. The strongest defensible claim is not we see the planet. It is the data can be fit by a planetary model, and the planetary signal may persist even when activity contributes noise. That's a careful inference, not a victory lap. And we have to make clear why this cautious stance is not weakness. It is exactly what exoplanet science demands when the signal sits near the floor of what's measurable. Because the next step, anything about the habitable zone, anything about an atmosphere, anything about future biosignature context depends on the orbit and mass constraints being trustworthy. If the detection foundation shifts, interpretation becomes a mirage. So we ask what elevates confidence in a planet interpretation without pretending the star is quiet. RV detections around active stars require multiple lines of validation, consistency checks, activity diagnostics, stability tests across time. That's not optional ceremony. It's the method's immune system. When the RV signal does not cleanly track activity proxies, when it retains some independence from the star's changing state that leans the argument toward a real orbital component, when independent ways of measuring and reducing the data converge on a similar periodic behavior that reduces the probability that what we're seeing is purely an instrumental ghost. But we also have to say what remains unresolved, because the outline insists we keep the boundary between knowing and inferring sharp. The unresolved hinge is token C, the RV line against activity cycles. A planet should be stubborn. A star can be seasonal. And in this case, the signal has refused to fit as a single perfectly stable story across time. That means the planet hypothesis can remain a best fit while still carrying an asterisk contamination, can widen the uncertainty, distort the amplitude, or partially overlap with the orbital rhythm. Now we name the limitation that belongs to this section explicitly, because it's not just uncertainty in the abstract. The confounder here is model assumptions, not assumptions about the planet's atmosphere. This episode isn't there yet, but assumptions about how we represent the star's behavior inside the RV analysis. If we choose a simplistic activity model, too smooth, too static, we can accidentally attribute stellar variability to the planet inflating confidence in Proxima b. If we choose an overly flexible activity model, so powerful it can explain anything, we can accidentally erase a real planetary signal, declaring the exoplanet a phantom. This is the quiet danger. The outcome can depend on how we parameterize the star. That's why the conclusion must stay modest. The RV curve is not a single fact. It's a measurement filtered through assumptions. It's physics plus interpretation, and that is the deeper meaning of real but not clean. It's not cynicism, it's precision. It's an insistence that the most important sentence we can say about nearby potentially habitable zone worlds is not maybe life, but maybe planet measured, honestly. because only then does the next era of questions become legitimate. Only then does it make sense to wonder what future constraints on an exoplanet atmosphere could mean, or how any future hint of signs of life would be weighed against false positives. If we skip this step, we don't just risk being wrong, we risk not knowing what kind of wrong we are. So we end this section with the kind of conclusion that science can live with. The method can detect tiny stellar motions. The star can mimic them. A planetary explanation for Proxima b can remain the strongest story even in the presence of activity, provided we acknowledge contamination and test for it. If the orbit and mass constraints become more robust, then Proxima b becomes a more stable foundation for future cautious discussions about habitability and atmosphere constraints, never as a shortcut to a life claim, but as a target whose interpretation won't collapse under its own uncertainties. And now the story narrows to a single measurable question, the one we still need answered before the RV line stops slipping between planet and star. Because the real ending isn't a proclamation, it's a requirement. We turn to what is limitation heavy by design, the specific unknown that can be measured, the confounders that must be separated, and the kind of future data that would finally make this RV signal stop refusing to fit. The calendar keeps turning. Night after night, a thin thread of starlight is collected, measured, turned into numbers. The marks accumulate like footsteps in snow, except the snow keeps drifting, reshaping itself between each print. The line we draw afterward is never just the record of a planet. It is also the record of a star that will not sit still. On screen, the observing nights stretch into a long band of time. Dots gather into a curve. The curve tightens, then loosens, then tightens again as more seasons are added. The story becomes less about a single discovery moment and more about endurance, how long you can keep listening without letting your hopes choose the answer for you. This is the limitation-heavy end of the title's promise RV line on Proxima b activity cycles versus Planet the Full Story. The full story is that the RV line has refused to fit perfectly because activity cycles are not a side effect around Proxima Centauri. They are part of the signal environment itself. So the key question now is not romantic, it's practical. What specific measurement would reduce ambiguity enough to turn Proxima b from a debated signal into a stable foundation, solid enough that future talk about an exoplanet atmosphere, a biosignature, or even a technosignature channel would be interpretation, not wishful thinking? We begin with the honest premise. When the signal is tiny, the strongest move is not to speak louder. It's to measure longer. Because the confounders here aren't vague. They have names, they have mechanisms, and they can be tested. First, stellar contamination. Proxima's surface can change on multiple timescales. Rotation, bringing features in and out of view. Longer activity cycles changing the baseline behavior. Spots and faculae distort line shapes, and those distortions can become apparent radial velocity shifts. This is not a maybe. It's a known pathway to false positive. Second, instrument systematics. Even if the star were calm, a system that measures tiny spectral shifts must remain extraordinarily stable. Wavelength calibration, drift thermal stability issues, detector effects, these can imprint structure into the RV time series. Not random jitter. Structure. The kind that looks like a story. Third, time variability versus sampling. If the observing schedule is uneven clusters and gaps, nature can conspire with our window of attention. A signal can appear stable because we only watched it in a particular stellar season. Then when the season changes, the signal changes, and it looks like the planet vanished or like the star calmed down, when in reality we simply moved our flashlight. Now the point of this section is not to pile doubt on top of doubt. It's to name the measurable unknown that can resolve the tension. Here it is plainly as the outline requires. The named unknown is the star's RV jitter spectrum versus time quantified as the RV activity correlation strength and its wavelength dependence across multiple activity cycles. That sounds technical, but the meaning is simple. We want to know whether the RV signal behaves like gravity or like the star's changing surface. And we want that answer not once, but repeatedly across the star's own cycles. So we ask three concrete things, all rooted in the same idea. Does the RV line rise and fall with activity diagnostic strongly weakly or inconsistently as time passes? A persistent, strong coupling points towards stellar contamination. A weakening or absent coupling, consistently observed, opens space for a real planetary component. Does the RV behavior change with wavelength? And does that wavelength dependence itself change as the star moves through different activity states? If the signal is chromatic in ways that track activity cycles, the star's case strengthens. Does the same story appear when you introduce redundancy, different observing seasons, different reductions, different instruments? If the signal survives independent pipelines, that reduces the odds that a single calibration drift narrative is writing the curve. These are not philosophical moves. They are the kinds of tests that turn a dramatic question planet or star into a patient measurement program. And notice what we have not done. We have not declared a life signal. We have not inflated a habitability hope into a claim. We have not treated nearby as easy, because even the most tempting future conversations about signs of life depend on this: what is the object we are interpreting, and what are the limits of the data that define it? So we place one cautious, bounded speculation where it belongs and we label it. If Proxima Centauri becomes a more secure RV target, if the star's activity contribution can be modeled and separated with higher confidence, then it becomes more scientifically meaningful to attempt future constraints that speak to an exoplanet atmosphere. Not because an atmosphere would instantly imply a biosignature, and not because any technosignature claim would be anything but speculative, but because interpretation requires a stable foundation. And then we return to the tone that fits this ending, quiet, unsentimental, and awake to what we don't know. The RV line is a whisper. The star is a storm. The difficulty is not that we lack imagination, it's that we have to subtract imagination from the measurement until only the universe remains. So the final title thread sentence lands like a verdict that refuses drama. The RV line on Proxima b has refused to fit cleanly because the star's activity cycles are an active rival explanation, and the only honest path forward is to measure the star's contamination signature so well that the planet's tug, if it's there, can no longer hide behind it. We end on an image that doesn't resolve into certainty. It resolves into a requirement. Starlight enters the instrument. Lines shift by a breath. A curve is drawn. And beneath that curve is a named, unknown, measurable testable, stubborn the wavelength-dependent coupling between radial velocity and stellar activity across multiple cycles. Until that coupling is mapped, the story stays open, not empty, just unfinished.